All right, so when we left off, we had defined the natural log, and we had a long list of rules for natural log. So let's just quickly review what those were. What was our definition of the natural log of x?
1 over x.
Ln x isn't equal to 1 over x.
It's the integral from 1 to x of 1 over t dt.
The integral from 1 to x of 1 over t dt, and x had to be a positive number. So that was our definition of natural log. And from that definition, we proved some things. I'm not going to list all the things we talked about the other day, but some of the important things we talked about was that the derivative of natural log is then 1 over x, using the second fundamental theorem of calculus. We had, what other important rules did we have? Ln of 1 equals 0. Any other important rules? Anybody remember? What about this one? What does ln do to multiplication?
ln A
Turns it into addition. A and B are both positive. And similarly, what does ln do to division? Turns it into subtraction. And rule number 6, we had what does ln do to exponents? Put some out front. Oh, and under this derivative 1, I probably should have added this. What happened if you didn't have just the letter x in there? What if you had some other function?
1 over g of x times g prime of x.
It was 1 over g of x times g prime of x, and that came from the chain rule. All right, so I think those were all of our important rules, the ones we're going to use today primarily. We had a few others. We had that ln was increasing. We had that it was concave down. We talked about its domain and its range. Those were the important ones. The last thing, as far as definitions and stuff go, is we define E to be the value such that ln of E equals 1. So that's that famous number E that you've probably seen in other classes. That's the way we define it in this class. We talked about the range. The range of ln was all real numbers. So there has to be a number such that the ln of some number equals 1. We don't know exactly what that number is, so we're going to call it E. How big is E, approximately? 2.72 something, I believe. Somewhere around there. 0.718. All right, so yesterday I was talking about there's some number such that ln of that number is 5,000. And I asked, does anybody know what that number is? And nobody could answer the question. It's really, really big, that's true. How big is really, really big?
Like 100 zeros after a 1?
I'm not sure if it's quite that big, but maybe.
Okay. I put in like 25 into the calculator and maxed it out, and it was only at 200. So.
Wouldn't it be e to like e to the x where x is equal to?
Wouldn't it be ln of e to the 5,000?
Yes.
That's exactly right. Here's the answer. The answer is e to the 5,000. Why is e to the 5,000 the right answer?
Because they cancel each other out when you do that. You take the base.
Okay, so you're using a property we haven't talked about yet. You're using the fact that the functions ln of x and e to the x are inverses, which is true, but that's in like the next section. So you're cheating a little bit. The way I would prove it to you is I would say, well, I can bowl that exponent down, And then I can use the fact that ln of e is the number 1. So yesterday I first said I don't know what the number is, and then I corrected myself and said, oh yes I do. But then nobody else remembered. So but I'd bring it back up today. There it is. Okay, so what we're going to do here is we're going to do some properties of logs. We're going to use them. So something you might see is like use properties to expand. And we might have something like ln of x squared times square root of x plus 1 divided by x squared plus 3 to the 5th. So we're not doing any calculus. We're just going to do a little algebra here at first. They want us to use the properties of logarithms to expand that. Well, what do they mean by expand it? We're going to use our properties to break it apart. In particular, we're going to use the multiplication property to write things as addition, and we're going to use the division property to write things as subtraction. So how would you break it apart?
2x plus square root. No, that'd be 2x plus 1/2 x distributed into that, okay?
You're forgetting an important thing, though.
Do subtraction first.
I'm not hearing any LNs is what I'm missing here. The LNs don't disappear. All right, so here's what I would do. You're doing it all in one step in your head. I think you know what you're doing. But what I would do first, the multiplication changes to addition. So I would write ln of x squared plus ln square root of x plus 1. And then the division changes to subtraction. So that's minus ln of x squared plus 3 to the 5th. And then what's the second step? Bring the exponents down. So this 2 comes out, it comes out as a multiply. The 5 comes out as a multiply. What happens with the square root? Goes in front as a 1/2. It's a power of 1/2. So our final answer would be 2 ln x plus 1/2 ln of x plus 1 minus 5 ln of x squared plus 3. So that's what they mean when they say expand it. Write it as a sum and difference of logs and bring all the exponents down that you can. Yes?
How do you know that the division on the bottom is for both terms?
What do you mean for both terms?
Oh, okay. The
entire x squared plus 3 was on bottom. So the ln, the x squared plus 3 got a negative. And these two were on top, so these two both have positive terms. All right, so here's one that will quite often confuse people. ln of, I'm just going to make it easier this time, how about x squared y cubed over z to the 5th w to the 6th. You know, don't get to use w very often. Throw in a w there. So what's going to happen?
2 ln x plus 3 ln y.
All right, so you're doing two steps at once, and that's okay. Once you've done one or two of these, I think you'll be doing that. So he took the multiplication, changed them to addition, and brought the powers down at the same time. That's fine. Minus 5 ln z plus 6 ln w. Okay, there's a mistake. Excellent. Notice that both the z and the w are on bottom. Since they're both on bottom, you're dividing by both of them, aren't you? So, there would be a correct answer. Now that forces the w to go down to the bottom. Or another correct answer, of course, would be to have a negative 5 ln z and then a minus 6 ln w. But that's a very common mistake that I'll see people make. When there's more than one thing on bottom, everything on bottom has to have a minus sign in front of it because they were on bottom. They came from division. I'll see a lot of people put a plus there, so watch out for that one. Questions on that? All right, conversely, instead of expanding, sometimes we use properties to combine. So this is pretty much exactly the opposite. You're going to start with something that looks like 1/3 ln of x plus 1 minus 5 ln of x minus 3 plus 2 ln x. So you're going to start with something that's expanded out, and they want you to combine it together and write it as just one single logarithm. So it's pretty much exactly the opposite of what we just did. So what would you write?
The ln out property.
We're going to have, when we get all done, we're going to have one single ln. Are we going to do it all in one step, or are we going to do a couple steps?
Cube root of x plus 1.
All right, so that 1/3 goes in as an exponent. You could either write it as an exponent 1/3, or you can write it as a cube root. That's good. Cube root of x plus 1.
And then that'd be divided by
That'd be divided by
x minus 3 to the 5th.
x minus 3 to the 5th.
What's that squared? Which whole thing? Oh, yeah.
The whole thing times x squared. If I'm going to multiply the whole thing by x squared, I can think of it as x squared over 1. And I can just multiply tops, multiply bottoms. In other words, the x squared goes on top. So, kind of the opposite rule here. Anything that has a plus in front of it, when you're combining it, anything with a plus is going to end up on the top, and anything with a minus in front of it is going to end up on the bottom. That's all.
So if you put parentheses in front of the 5 and after the whole thing, then just that should get bottom, right?
Correct. If I'd given you this problem, very similar problem, 1/3 ln of x plus 1 minus 5 ln of, I forget what I had here, x minus 3 maybe, plus 2 ln x. You're absolutely right. Now, because that thing on the right is in parentheses, if I distribute that minus sign through, I would have a minus 5 and a minus 2, wouldn't I? So since I have the minus 2, that one's going to now go down to the bottom. So the answer there would be ln of x plus 1 to the 1/3 divided by x minus 3 to the 5th. And then the x squared would go on bottom that time because you distribute the minus through, it's got a minus in front of it. Correct. Other questions? All right, so now let's do some calculus. Find the derivative. So I'm going to give you the function f of x equals ln of x squared plus 9. What's the derivative?
2x over x squared plus 9.
2x over x squared plus 9. Perfect. And how did you get 2x over x squared plus 9?
It's 1 over f of x times f prime of x.
It's 1 over whatever's inside these parentheses. So the x squared plus 9 goes on bottom. And then you multiply by the derivative of whatever's inside there. That's 2x. That's perfect. There's your derivative. Questions on that?
So it's kind of the chain rule.
It's exactly the chain rule. Absolutely. Because if I had just ln x, then the answer would just be 1 over x. As soon as I have anything different in there, it's 1 over whatever the thing is in there times the derivative of the thing. It's exactly the chain rule. 100% the chain rule. All right, how about g of x is x squared ln x. The derivative is
Over 2x over x.
2x over x. No. What fatal mistake did he make? It's product rule. How do you know it's product rule? There's multiplication right there, isn't there? It's x squared times ln x. So this ln x is a new function, but our old rules don't go away. We still need the product rule. So I leave the first one alone. That's x squared. I take the derivative of the second one, the derivative of ln x, 1 over x, plus I take the derivative of x squared, 2x, and I leave the second one alone. I leave the ln x alone. So there's the derivative. Product rule, don't forget about the product rule. Still got to use that.
Would you want this simplified?
Really like that.
Or
As far as I'm concerned, you can leave it just like that. And I'm pretty sure WebAssign would accept it just like that. But it is a pretty easy one to simplify. And you reduce the x squared and the x. You could write it as x plus 2x ln x. And I think that's the best you could do. I suppose if you really wanted to get crazy, you could factor an x out. But I wouldn't do that. Do you have another question?
Well, do those other properties apply to that 2x ln x? So would that be, I'm just wondering if it would, can you put that x in the exponent?
Absolutely. So his question is, this is kind of weird, but this 2x ln x, you could write this as x plus ln x to the 2x. Absolutely you could. Normally we don't, but yes you could.
Think WebAssign would take that?
I don't know. That's a good question. I don't know if WebAssign would take that or not.
So if you get
Try
wrong
it.
answers,
See what it says.
if you get wrong answers,
if we do we get bonus, we stump WebAssign with the correct format.
Sure. Well, except now you can't use that one because it's his idea. All right. How about h of x is? How about its sine of x divided by ln of cosine x? Well, then h prime of x is?
keep first.
Which rule do you have to use? Quotient, because we definitely have division. Quotient starts with, you leave the bottom alone, that's ln of cosine x, times the derivative of the top, cosine x, minus the top, that's sine x, times the derivative of the bottom. All right, what's the derivative of ln of cosine x?
1 over cosine x times negative sine x.
1 over cosine x, it's 1 over whatever's in there, times the derivative of what's in there. The derivative of cosine x is negative sine x. And then the whole thing gets divided by ln of cosine x squared. Questions on that one? All right, how about y equals ln of x squared times the square root of x plus 5. What do you have to do in order to take the derivative of that function? What's that? Use substitution. Use substitution is for integrals, not derivatives. No integrals yet. That's the next section.
1
Okay.
over x squared plus 5 times the derivative on the inside.
All right, so you're just going right ahead and you're using the chain rule.
Or you get chain
That's
rule
perfect.
inside
All right, so y prime
the chain rule
would be
inside the line.
1 over that whole conglomerate. So it's 1 over the thing, 1 over x squared times the square root of x plus 5. But then you have to use the chain rule, which tells you got to multiply by the derivative of the inside. And unfortunately, the derivative of the inside requires
Another thing.
in the product rule, doesn't it?
You just split them apart.
Ah, yeah, now you're doing it the smart way. We're going to do this problem again. We're going to like it so much. All right, so I'll leave the x squared alone. Take the derivative of the second one. I bring the 1/2 down. X plus 5 to the negative 1/2. And then I need to multiply by the derivative of the inside of that. But the derivative of the inside of that is a nice thing. It's 1. Plus, I didn't leave myself enough room. I take the derivative of the first one. That's 2x. Leave the second one alone. X plus 5 to the 1/2. So there's a correct answer. That was the hard way. Here comes the easy way. What was your easy way?
Splitting it apart.
Use properties of logarithms to split it up. So what's that going to do for you? Multiplication, which means you don't need to use the product rule. Because it's going to change multiplication into addition. What else is it going to do? It's going to get rid of the exponents too. If you split it up first, this is 2 ln x plus 1/2 ln of x plus 5. So that's really why in this class we talked about those properties of logarithms. It makes life a whole lot easier. Now I take the derivative. Y prime is 2. What's the derivative of ln x? 1 over x. Plus 1/2. What's the derivative of ln of x plus 5? 1 over x plus 5. And technically you still need to use the chain rule, but the derivative of x plus 5 is 1. Which derivative looks nicer? If you had to simplify it and find critical points, which one would you rather work with? I would hope you would all agree that I'd much rather work with the second one. The second one looks a lot more simple to me. Okay? So there's an advantage of using properties of logarithms.
So you can break it apart before you take derivatives.
Absolutely, you can break it apart before you take derivatives. And that leads to something called logarithmic differentiation. Big words.
Is this like 5.1b?
Still section 5.1, yep. Haven't done anything out of 5.1 yet. Let's say I gave you f of x. I'm going to call it y. I should have just left f of x equals y equals, let's say it's x squared times x plus 2 to the 5th divided by x minus 3 to the 8th. How would you feel about taking the derivative of that? Depends.
Well, if you could use natural log.
Well, there's no natural log there. If I had a natural log in front right here, you could split it all up. And that's exactly what you do. And this is called logarithmic differentiation. What we do is we take the logarithm of both sides. How come you don't want to take the derivative of that just the way it is? Pain in the neck, isn't it? You got to use the product rule, the quotient rule, the chain rule, like 5 times. Not a good time, is it? All right, so what we do is we do logarithmic differentiation. So I'm going to write ln y equals ln of x squared times x plus 2 to the 5th over x minus 3 to the 8th. Why can I do that? Why can I put ln on both sides? You can do almost anything as long as you do it to both sides. There is a restriction. True, you can't divide by 0. You can't do that on both sides. You can't multiply by 0 either.
You can't square both sides if it's negative.
Right, you need to be careful. You can't square both sides sometimes. You got to worry about dealing with negative sides. What's wrong with x squared is x squared is not a one-to-one function. Right, it doesn't pass the horizontal line test. ln, because ln is always increasing, it's a one-to-one function. So you can do ln on both sides and you don't mess up the equation. So we do the ln in order to split this up. So we're going to write this as 2 ln x plus 5 ln of x plus 2 minus 8 ln of x minus 3. And we just eliminated the quotient rule and the product rule. We're going to need the chain rule a little bit, but it's a very easy chain rule at this point. Bless her. Now we take the derivative. On the left-hand side, what's the derivative of ln y?
1 over y.
Close. What's that? It's 1 over y, and then I need to take the derivative of the inside. What's the derivative of y? dy dx, or I could call it y prime. So that goes back to Calc 1 when we did something called implicit differentiation. When you take the derivative of a y, there's always a y prime, or a dy dx if you want. Equals. Take the derivative over here, that's 2 over x plus 5 over x plus 2 minus 8 over x minus 3. And for those last two, I technically needed to use the chain rule, but the derivative of the inside on both of them was just a number 1. So that was very easy. All right, so here's my final answer. My final answer is y prime equals x squared times x plus 2 to the 5th divided by x minus 3 to the 8th times 2 over x plus 5 over x plus 2 minus 8 over x minus 3. Where'd that come from? Yeah, where'd that come from?
Because there's that 1 over y.
There's that 1 over y, so I multiplied by y, and that y was the original thing, so I plugged it back in. So that's where it came from. I multiplied both sides of the equation by y
To get rid of that 1 over y.
to get rid of that 1 over y, because I wanted the y prime all by itself, but that y was the original function, so I stuck that back in there. All right, so that's a technique called logarithmic differentiation. It's a way to take derivatives and being able to avoid having to use the product rule, the quotient rule, and the chain rule a lot. Is it easier?
Much.
Much?
Yeah.
You don't like it? And that's the way it usually goes. People are usually split on it. Back in Calc 1, I did a lot of problems with the product rule, the quotient rule, and the chain rule. I'm really good with those now. And so although this is kind of ugly, I'm pretty confident I can do it and get the right answer. This is new, so it's kind of different. So it looks a little weird.
So if you did it the old way, it'd come out to that exact thing? Or would it be like distributed?
It would be something kind of like what we saw in the last problem. They would be exactly the same, but they would look very different.
But they come out to
But if you simplified them, combined all your like terms, got common denominators, they would be exactly the same. But the answers look very different. I mean, this one and that one. Mm-hmm. When you already start with a log function, using those properties is real nice. The derivatives come out a lot better. But it worked using the product rule, chain rule, all that stuff we're used to. So, like I say, this problem here, you could do it two ways. You could do it, I mean, this is a problem that you could do from what you learned in Calc 1, and you would get an answer, and it would be the same as this, but it would look very different.
For another test, you're going to say, use one.
On the test, I would say use logarithmic differentiation to find the derivative. Yes.
Or we could check it.
Huh?
Or we could check it. We're allowed if we want to.
Well, it would be very easy for me to check. If I don't see an ln y equal, right? If you didn't follow directions, it's going to be very easy for me to tell that you just did it the Calc 1 way. Won't be any doubt in my mind at all. Other questions? Want to do one more of those just to be better? All right. So, y equals. Make up some ugly function for me. Cube root
9 minus x.
9 minus x.
Square.
Whole thing squared?
The whole thing cubed.
I don't know.
Or just the x squared?
Yes.
X squared. All right. times
X to the, like X to the fourth.
x to the 40th. No, I'm just kidding, x to the 4th. Although 40th wouldn't really matter. X to the 4th
Minus 2.
minus 2 inside a parenthesis.
I don't know.
Sure.
Yeah.
All right.
To the third.
To the 3rd. All right. And then let's divide by something.
13.
13.
No, 13x.
How about x to the 13?
Yeah.
Once again, that is a problem that I could do from the techniques that I learned in Calc 1.
I think I tried it.
You think you try it the other way?
I
Just-
tried the new way first.
All right, let's try the new way first. So the new way says ln y equals, and I take the ln on the right-hand side. Are we comfortable with me expanding the right-hand side all in one step? All right, so what's going to happen? We're going to have a 1/3 ln of 9 minus x squared plus a 3 ln x to the 4th minus 2 minus 13 ln x. We take the derivative. On the left-hand side, the derivative of ln y is 1 over y dy dx. Or if you prefer y prime, you can write y prime. Equals. Here I'm going to have a 1/3. 1 over 9 minus x squared times negative 2x. So I do need to use a little chain rule there still. I didn't eliminate all of the chain rule, but I eliminated most of it. It's 1 over the thing times the derivative of the thing. So that's where that derivative of negative 2x came from. Same with this one. This is going to be 3 times 1 over x to the 4th minus 2 times 4x cubed. Same thing, chain rule there. Minus 13 over x. Final answer is still not very nice. I mean, I didn't say these were going to be terribly pretty, but I think it's nicer than the way it would have looked if we'd have used the Calc 1 rules. dy dx is, I'm going to multiply by that y, so I'm going to have cube root of 9 minus x squared times x to the 4th minus 2 cubed divided by x to the 13 times negative 2x over 3 times 9 minus x squared plus 12x cubed over x to the 4th minus 2 minus 13 over x. Questions on that?
How did they come up with this?
Yeah. Jeez.
Don't know.
I was using a calculator, so.